Determine the formula for the given sequence. Whenever we have a sequence of fractions, it's often helpful to analyze the sequence of the numerator and the sequence of the denominator separately. But also notice this sequence alternates signs. The sequence begins with a negative, then a positive, then a negative, then a positive, and so on. So what we'll do is analyze the non-alternating sequence, find the correct formulas, and then we'll adjust that formula so that it alternates a sign using either -1 to the power of n or -1 to the power of n plus 1. Let's first consider the sequence of the numerator without the alternating signs. We have 9, 11, 13, 15, and so on. And for the denominator, we have 4, 16, 64, 256, and so on. Let's start with the numerator. Looking for a pattern, we should recognize a pattern of addition. Notice 9 plus 2 equals 11. 11 plus 2 is 13. 13 plus 2 is 15, and so on. Recall repeated addition can be expressed using multiplication. We might be thinking the correct formula is going to be a sub n equals the first term of 9 plus multiples of n, or plus 2 times n. But we saw in the previous lesson this doesn't quite work, because notice for a sub 1 we know a sub 1 must equal 9, and the current formula would be 9 plus 2 times 1, meaning we start with 9 and add 2 once, which we don't want to do. Starting with 9, we want to add 2 0 times, not 1 time, and therefore we don't multiply 2 by n, we multiply 2 by n minus 1. Notice using this formula, for a sub 1 we'd have 9 plus 2 times the quantity 1 minus 1, which is 0, which does give us 9 the first term. Let's check a sub 2. A sub 2 is equal to 9 plus 2 times the quantity 2 minus 1, or 1. This should make sense. To get the second term, we take 9 and add 2 once, which does give us 11. Let's check a sub 3. A sub 3 is equal to 9 plus 2 times the quantity 3 minus 1, or 2. To get the third term in the sequence, which is 13, we start with 9 and add 2 twice, or add 2 times 2, which does give us 13. So now we have the correct formula for the numerator, again, not using the alternating signs. And now let's look at the denominator. Analyzing the sequence, notice the pattern of multiplication. We have 4 times 4 equals 16. 16 times 4 is 64. 64 times 4 is equal to 256, and so on. Recall that repeated multiplication can be expressed using exponents. Also notice 4 is equal to 4 to the first. 16 is equal to 4 squared. 64 is equal to 4 cubed. And 256 is equal to 4 to the fourth power, which indicates the correct formula for the denominator is simply a sub n equals 4 to the power of n. So now if we take the formula for the numerator and divide by the formula for the denominator, we'll have the correct terms, we just won't have the correct signs. And I should also mention we can simplify the formula for the numerator by distributing 2. Let's also show that. We have a sub n equals 9 plus 2n minus 2, giving us a sub n equals 7 plus 2n. We can also express the formula for the numerator in this form. And now let's begin to build the formula for the original sequence. We know a sub n will have 7 plus 2n in the numerator, and the denominator will be 4 to the power of n. And now to work on getting the correct sign, we simply need to add a factor of -1 to the power of n or -1 to the power of n plus 1, depending on whether the first term is positive or negative, and then from there they alternate. Well, we know -1 to the power of 1 is equal to -1, so let's use -1 to the power of n. Notice when n is 1, meaning we're looking for the first term, we have -1 to the first power, which is -1, and then times the formula we know works for the numerator and denominator. A sub 2 would give us negative 1 to the power of 2, or negative 1 squared, which would give us positive 1, and notice the second term is positive. So this is the correct formula, but let's go ahead and check a couple terms. For a sub 1, we have negative 1 to the power of 1 times 7 plus 2 times 1 divided by the quantity 4 to the power of 1, which gives us negative 1 times 9/4, which is negative 9/4. Let's check a sub 2. A sub 2 equals negative 1 squared times the quantity 7 plus 2 times 2, all divided by 4 squared, which does give us positive 1 times 11/16, which is, of course, 11/16. Notice our formula for the original sequence is correct. I hope you found this helpful.